Welcome to PVsyst. In this tutorial, we will walk through the user interface of the software. We will show you how to navigate PVsyst to properly design and simulate your projects. This is the main dialog of PVsyst. Let's bring our attention to the menu bar at the top and walk through some of the options. The most important place to start is the language option. From here, you can change PVsyst's interface to display in another language. You can find the global preferences in the software under Settings, Preferences. The other menu items, File, Preliminary Design, and Project, will be explored as their tools become necessary in other tutorials. The Help menu will allow you to reach the help file for PVsyst, as well as other resources such as tutorials and other places on the website. You can also access the help file and some of these valuable resources in the documentation frame. The help file is an extensive tool that explains the functionality and the underlying fundamentals of PVsyst. You can access the contextual help file from anywhere in the software by pressing F1 on your keyboard or by clicking on any little question mark buttons for more targeted information. Don't hesitate to use the help file if you have any doubt while using PVsyst. The topmost frame of the main dialog includes the main tools. The top three buttons are used to start and edit projects of different types. There are grid-connected, standalone, and pumping systems. In these tutorials, we will focus on grid-connected systems. Below are the utilities. Databases manages locations, weather data, and PV components. In PVsyst, we refer to weather or meteorological data as meteo data. Tools brings up some solar and electrical tools for pedagogical use. Measured data handles measurements on real systems and compares those measurements to simulation results. This is an advanced feature. Next, the Recent Projects frame allows for quick access to any recent projects. Finally, you have the User Workspace frame. Here, you can manage the location of your own files used and generated by PVsyst on your computer. You will not need to manage it during your first steps in PVsyst. There will be a separate tutorial explaining the workspace in greater detail. Now, let's take a closer look at two of the important dialogues: databases and grid-connected projects. Open the database dialog. On the left, you have full management of the geographical locations and the associated meteorological data. On the right, you can manage the components used in a PV system. Open geographical sites. You have a list of geographical sites predefined in PVsyst all around the world. You can sort them by country and choose any of them. But you can also create your own site anywhere on the Earth by clicking New and choosing it on a map. You can also import meteorological data for this site from different databases. Several other options exist for the management of meteo data. Synthetic data generation will create an hourly data file from monthly values. You have a tool for visualizing and checking your hourly meteo data and for importing them from a variety of data sources. These options will be explored in other tutorials. To illustrate the management of PV components, open PV modules. The available components are listed by manufacturer, and there are some filters for facilitating the choice. By double-clicking a module, you get a dialog with its properties. You can see graphs of the behavior of this module, modify its parameters, or create new ones. There will be several videos explaining the management of each component. Click on Grid Connected to explore the project dialog. Using these buttons, you can start new projects, load existing projects, and save your project. Load the demo residential project. Projects are more thoroughly discussed in another video, but you can see two main frames here. The project frame contains project-level parameters that are shared by all simulations in a project. This includes the site and Medio data. The Project Settings button brings up other project-level parameters, such as albedo and system limitations. We will explore these settings in another tutorial. Below is the variant frame. Each variant contains system parameters and will produce its own simulation result. You can create as many variants as you want within a project to compare different design decisions or evaluate the system as it becomes more complex. For this tutorial, select variant VC1. These buttons access the dialogues that describe in many levels of detail the PV system for the simulation. We will explore these tools in another tutorial, but let's look at a few key tools now. When defining a variant, the first operation is to define the orientation of your PV array. There are many different orientation modes to choose from, including tracking. Then you have to define the system configuration. In the blue frame, we can choose a PV module from the database. In the green frame, we define the inverter. The gray frame defines the array properties, i.e., the number of PV modules in series and the number of strings in parallel. Note the blue dialog box here. Throughout all of PVsyst, there are blue dialog boxes like this one that will display information relevant to the current windows. If the text in the box is blue, then this is just an informational message. If the text is orange, this is a warning that something is not optimized. However, with orange warning messages, the simulation can still be run. Finally, if the message is in red, this means there is an error that needs to be corrected before you can run a simulation. Another important feature of PV simulations is the shading analysis. For this, a 3D representation of the PV installation is required. This can be accessed in the Near Shadings tool. We will see various tutorials on the details of this tool later in this course. Right now, let us just have a quick look at the 3D editor. Click on Construction/Perspective to bring up the Scene Construction tool. This CAD interface shows the drawing of the PV system. In the main window, you can see a simple house with the PV array in blue and some nearby structures that will cast shadows onto the PV array, depending on the sun's position. To see the drawing in a more realistic way, click on Render. We can see the shading animation by clicking on the Tools tab in the right and launching the animation. Close the scene and the Near Shadings tool by clicking on Cancel to return to the project screen. The other buttons also access dialogues that allow you to define the different properties of a PV system. We will go in more detail through all of them in other tutorials. To the right of these parameters, there are simulation controls. Here you can run a simulation by clicking on Run Simulation. In this demo, the simulation has already been run. just click Yes to run it again. There are two main ways to view results: these detailed results or the report. The report will organize all the system parameters and the simulation results into a printable document. The number of pages will depend on the complexity of the variant and the report options. This page contains all the main system parameters. The loss diagram is the main result of the simulation. It summarizes the energy flow in the PV system. The other buttons can show details of any result of the simulation tables, graphs, and other diagrams. Here we gave you an overview of the user interface in PVsyst. See further tutorials for more details on how to use the various tools throughout the software.